Okay, so we're going to look at interpreting functions and interpreting, I suppose, graphs of functions. And this is maybe the area within functions that I think people tend to find the trickiest. And a lot of it comes down to really understanding the question for the most part. And I know that's true for basically everything we do. But I think particularly here, if you can interpret the question, you will be much better able then to interpret the graph. And the question will tell you a lot more than you might think it does on surface level. So it's about kind of just taking that extra time to really break down the information that they've given you in the question. So what I've tried to do here, I suppose, is to separate out some of the common types of questions that you can be asked, and to really do that, to break down what is it that they are telling us within this question, and how can that help us then to answer the question or to work out the value that they're looking for us to find. So in terms of that, I suppose, looking at the first example here on interpreting functions, the first question says we're looking to find f of k. F of k. So the note I've made for myself here is, what do we know? And we should hopefully know that in any normal question with functions, we usually see that idea of f of x, where this thing inside the bracket would be the input, and we know that inputs usually use the letter x in terms of our functions here. So in this question, if they've given us some value for that input, if they've said here's something in this bracket, it's f of 3 or f of 7 or f of whatever, they are telling us that that is the input they want us to use. So therefore, that means the only thing we could be looking for is the output that would go with that. And we should be able to do that algebraically. Okay, going back to some of the function videos that we would have had earlier, we should be able to do that if we were given the function itself and do it algebraically, fill in the input, work out what the output would be. Obviously in these questions though, we're trying to look at doing that using the graph. So instead of using the actual algebraic function, we want to use the fact that every function is made up of points, of x's and y's, inputs and outputs that are plotted on a graph. So if we know one of those, either the input or the output, we should be able to use the graph to identify the other. So in this case, if we know the input, we can go to that input. So like we've done in one of these examples here, if I know that the input is 1, I can go over to where x is equal to 1, and I can draw a line upwards until I meet my function to kind of highlight what point that is on my function on the curve. And I can then go across to the y-axis to see the corresponding y value. Like in essence, all I'm doing there is I'm going to the point on my graph or on my curve that has that x value, and I'm seeing what the y value is at that point as well. So really, if you were to kind of circle the coordinate, you could probably work out the value as well, but we really want to spell it out here and really kind of show off our knowledge. So we go to the x-axis, we draw our line upwards, we draw our line across to the y-axis. And that should hopefully help us to kind of really make it really clear exactly what it is that we're doing. But we're essentially looking for the point on our curve on our function that has that corresponding x or y value as necessary. Okay, and that's going to largely depend on the type of function that we're using to some extent as well. But for the most part, that's what we're following. So you can see here, breaking down that idea of knowing what we're looking for really helps us to kind of solve the question there. The next example is a specific case, f of x is equal to 0. So what we know already is that f of x is interchangeable with that idea of y. Both are ways of writing output. So f of x is quite explicit in that it's the output for x for an input, whereas y obviously is just more general, just represents an output in general. But f of x and y interchangeable there. So what they're really asking us in this question is, for my function, when is y equal to 0? And we should know that on a coordinate plane, y is equal to 0 along the x-axis. So all the way along this line here, y is equal to 0. The reason that's important is that if we are asked to find the x values for when y is equal to 0, we are looking for the 2 points on my function that are on the x-axis. And that again is going to depend on the type of function that you have. If it was a linear function, it would only have one point where it crosses the x-axis. A quadratic function will typically have two, maybe not always, but for a lot of the ones we do, it probably would have two, and so on and so forth. Cubics would have three, and so on and so forth. The reason I'm saying this is a specific case as well is that beyond the fact that they've told us y and we are looking for x, f of x equal to 0 is actually setting up a quadratic equation if the function is quadratic here. So say the one that's in the example here, x squared minus x minus 2, if that's my function, if that's my f of x, then the question of f of x equals to 0 is essentially me saying when is x squared minus x minus 2 equal to 0? Okay, that's essentially what I'm being asked there. When is x squared minus x minus 2 equal to 0? And I suppose, as we've said, the reason that that could be most important is that's essentially a quadratic to be solved, and we would get our two answers or our two roots for the quadratic. So the point where it crosses the x-axis, they have a specific word. They're called the roots of the quadratic. We can find them algebraically by solving our quadratic, putting it equal to 0. We can find them graphically by seeing where our graph crosses the x-axis. The third example here is like an extension of that, where instead of it being equal to 0, we're picking a different value for y. So it might be y is equal to 3, 1, minus 2, so on and so forth, any y value at all that they've used. And we're going to do the same idea again. So we identify the fact that what they've given us is a y value, so therefore we are looking for an x value. And I suppose it's impossible to say how many x values we could get. Typically for a line it will be 1, for a quadratic it's often 2, it could be 1 if it was a particular point at the end, but it's typically 2. Your exponentials is typically 1. Really depends on the type of function that we have, but we're looking for x here, so it's the same idea again. We'll draw a line across for that particular y value with the goal of identifying where on our curve or on our function, on our graph, does that y value occur, and we will pick out any and all of those points, and then we'll identify the specific x values for those points. So again, it's breaking down what we've been told, but also what we're actually looking for. Describing when a function is positive or negative. This can often be one that people find particularly tricky. So we know that idea that a function being positive, okay, the question that you'll be asked will typically be, when is f of x greater than 0? And we already know that f of x stands for y. So they're really saying, when is y greater than 0? A big part of this is the idea that functions are made up of inputs and outputs. Inputs are things we provide. Outputs are produced by the function. So we can input anything. We can use basically any input we like in the domain, but the outputs that come from the function are specific to the function itself and how it interacts with those outputs. So when we're talking about a function being positive or negative or specific behavior of a function, it's typically going to be the y values that we're talking about in that case. So like here, when we're asking about the function being positive or negative, that is going to be the y values. Are the y values positive or are the y values negative? The way that we solve these questions is, and I suppose the same goes for any inequality, if the question asks you when is f of x greater than 0 or when is f of x less than 0, your first port of call, the first thing you are going to look at is when is it 0? Obviously these two symbols are inequalities, and inequality by definition means not equal. But what you're going to do is you're going to start with when it is equal, because that's going to be a key point for you, or points for you, in answering the question that follows. If you can find where the function is 0, which in this case is where it crosses the x-axis, then you will know that either after those points, or between those points, or outside of those points, your function should be positive or negative. Looking at this partly as an example here, let's even just use the first half of it here. I'll just ignore this side for the moment. Let's just look at this first half. I want to say where this function is positive and negative. So I need to start by seeing where it is 0, where it's kind of neither, I suppose. So where is y 0? Well, y is 0 at 2 points here and here. So x equals -3 and x equals 2. Between those 2 points of x equals -3 and 2, that would be this whole section here. And if we look at this section, this is all positive. All of these y values are positive. Outside of those points, we have negatives, okay? After 2 and less than -3, we have negatives. So if I want to say when it's going to be positive, I need to go between -3 and 2. And the way that we would write that is very similar to what you would probably see in the question when they're referring to the domain. If you were unable to do that, I would still write it in words. Even just to kind of identify that you do know what you're talking about. Ideally, you would write it mathematically, but if not, write it in words. Same goes for negative. So here, this is negative when x is less than -3. No, excuse me. Or when x is greater than 2. Okay? So being able to identify when it's positive and negative, it is a little tricky. And some of that comes down to being able to write it mathematically. So focus on, can you tell me, can you say in words when it's positive or when it's negative? And then you can work on trying to translate that to maths. But even if you could say it in words, first of all, then at least you're on the right track. Increasing and decreasing can be a little easier to see. A function is increasing if it's going upwards from left to right and decreasing if it's going downwards from left to right. Typically what you're going to be looking for there is kind of highest points or lowest points, because those are points where it kind of changes, where it turns. Okay, they're turning points. So for the ones we're looking at, it's probably mostly quadratic curves, which would have one turning point up at the top. So a curve like this would be increasing for the first half and decreasing for the second half. So being able to identify where that is the case. And again, we've said that it comes down to those key points for the function. And for this function, the key point would be the point where it changes direction, the turning point. So if you can find the x value there, you're going to be using that to refer to your answers. Okay. Turning points then we've kind of covered there. So let's look at an example, because I feel like this is all becomes very abstract and I've had, 12 minutes of me just talking without doing an example yet. So let's look at an example. We have a graph x squared minus 4x plus 3. So it's a quadratic graph. We can see obviously that the graph is a quadratic, but even just from the function, it's a quadratic curve, it's positive, so it's U-shaped, it has a minimum point, all of these things that we would, hopefully expect to see. First question says, find where f of x is equal to 0. F of x being equal to 0 means that y is equal to 0. So I'll go to my y-axis, which we know is the horizontal axis, and y is 0 on this line, because obviously we've 1, 2, 3, so 0 on that line there. What you want to do is you want to see, where does your graph cross that line? Like, where is your graph on that line? And there's only 2 places, at 1 and 3 here. Now, since this question has told us what y is, then the answer must be what x is. So all we need to give in our answer is just the x values. Okay, so x equals 1, x equals 3. If we were asked for coordinates or points, we would give that corresponding y value also. For the next one, f of x is equal to 3. Again, we know that f of x is the same as y. So they're saying here, where is y equal to 3? And that would be here. Now, obviously, we've got lucky here, and that point is on my graph. But let's just draw a straight line across for y equals to 3. And I want to see where that line hits my curve, my graph. So one of the points is here, and the other point is here. So let's work out the 2x values there. So for the first one, it's x equals 0, and the second is x equals 4. Let's do the third part here, f of 2. So here we need to, again, first of all, work out what it is that they've told us here. This 2 is in the place that x usually is. So they're telling us here that x is 2, which means we are looking for y this time. So let's go to where x is 2, which is here. Obviously, we need to give an answer here that's relevant to my graph. So I need to go to my graph. So I'm going to have to go downwards and across then to the y-axis, and we'll get -1. So y equals -1, or you could say f of 2 equals -1. The minimum point, the lowest point on my graph, we can see it kind of clearly. It's this point here. They've said point, so we need to give coordinates here, which means an x and a y part. That is going to be 2 minus 1. It's actually the same answer we had in the last part. Okay, the range of values for which the function is negative, f of x being less than 0. So we already know that that means where y is less than 0, that is going to be this whole section here below the x-axis. One of the things we said when we were going through this just a few minutes ago was to start off, look at where y is 0, which is the points 1 and 3, my two roots of my function. And I have to decide, even just in words, am I looking at the point between those two x values of my function, or is it the point to either side of those two x values? And here I can say that between this, for this whole section I'm shading in here, for all of that point part of my function there, the y values are negative. So for x values between 1 and 3, the y values will be negative. So let's try and write this mathematically now. So we use our inequalities, and it's x less than, so x greater than 1 but less than 3. The range of values of x for which the function is increasing. So looking at my graph here, I would say that my function is increasing after this point all the way upwards. We said that increasing and decreasing will all be centered around that turning point, that maximum or minimum point. And you have to decide if it's to the right or to the left of that. Here it's going to be to the right, so it's for x values that are bigger than that turning point. So x values that are bigger than 2. So hopefully we're getting a sense of how to break down the questions that you're being asked and kind of use them to answer the different, to answer the questions, I suppose, to kind of interpret your graph in the correct way. So we'll pick one or two more of these different questions to look at. Looking at the first part of this one, I might just do bits and pieces of them. Looking at the first part, we're asked to identify which graph is which. That's going to come down to our understanding of the functions. We have x squared plus 2x minus 3 minus x squared minus 2x plus 3. The difference between the two functions there comes down to the coefficient of x squared. The coefficient of x squared on the first one is positive, and that would expect a u-shaped function. And the next one is negative, so we expect an n-shaped function. So they actually go in the right order. They're f and g there in that correct order. This second part asks us to identify the roots of the function. We should hopefully remember that the roots are where y equals to 0, so these 2 points here. For each of those relevant functions, remember that the roots are the solutions to the quadratic equation as well. There is a second part there, but I'm not going to worry about that one. I want to do another kind of full interpreting one here, so I'm going to try part B of this function. So we're asked first of all to draw the graph of the function minus x squared plus 4x minus 1. So drawing the graph first of all, let's kind of have a think about what we're expecting. We are expecting here to see a negative quadratic because this minus in front of the x squared. So I'm expecting a negative quadratic. Let me try and do my input and output table. Don't think I have my calculator ready to go, so we'll... Okay, so you could do your input and output table here using your calculator. You'd fill in those input values, you'd fill in your function, you'd get your corresponding output values. I'm going to try and fly through them here as quickly as I can. So that'll be -1 first of all for x equals 0. 1 squared minus 1 plus 4 minus 1. That's 2, I think. 2, 3, 2, minus 1. And so minus 25 plus 20 is minus 5 minus 1 minus 6. Okay, so we're probably looking at a function here where the domain we've been given actually doesn't lead us to a wholly symmetric curve. If we'd gone back one more step to a minus 1, we would probably have a much more symmetric curve, but we'll go with what we've got. Remember that when you get your inputs and outputs, and you should be able to do them even without the calculator. I suppose that's quite important also. So all I've done there is fill in those different x values into the function and worked it out to get the corresponding y value. We'll maybe take that extra step of writing them together as a coordinate or couple pair here. And that'll be what we'll be plotting onto our graph. So let's do those. So 0, minus 1, 1, 2, 2, 3, 3, 2, 4, minus 1, and 5, minus 6. So let's line them up here. And drawing our curve as nicely and as cleanly as we can there. I might have gone a little bit off at the end. Okay, so the values of x for which f of x is equal to 2. So take stock first of all. You need to ask yourself, what is this telling me? Well, I can see there x is still in the question. So I'm straight away going, well, I probably will not know what x is here. I'm probably looking for y. And then we remember that f of x is the same as y. So they're asking us, where is y equal to 2? So we were correct. So we need to go to y equals to 2. We will draw our line across until it intersects with our function. We would expect it to intersect in 2 places, so we'll draw our lines down there. And the 2 places that we've seen intersection are x equals 1 and x equals 3. We're asked now for the values of f of 3. The 3 there is in place of x, so they're telling us x is equal to 3. X is equal to 3. Okay, so let's go to where x is equal to 3. I suppose we've already literally just looked at that one. It's kind of the reverse of the one we just did. So f of 3 is going to be equal to 2. F of 3 is equal to 2. The maximum point of the function, that's the highest point, which in this case is up here. Since we've been asked for point and coordinates, we need to give both. So the x part is 2, the y part is 3. The values of the roots of the function. So the roots of the function are where it crosses the x-axis or where y is equal to 0 on the x-axis. The solutions to the quadratic. So we're actually given the quadratic here, so we could solve it if we needed to. But let's just look at where those would be. That would be this point here and this point here. Okay, so again, we're estimating kind of what they could be. And we really have to just estimate here based on our answer. So we might say 0.4 and 3.7. Okay, generally in cases like that, there will be some tolerance, but on the other hand, they will often give you ones that would lead to answers like that, so that you have to have used the graph. Okay, the values of f of x are values of x such that f of x is greater than 0 and less than 0. Okay, the key thing we've said for answering a question like this is to start with where is f of x equal to 0. And we already have come up with 2 answers for that, so we will use those 2 answers. Our next thing is to decide, even just verbally in words, where or how would I describe the 2 answers for these 2 parts. So for the first one, where f of x is greater than 0, that's where f of x or y is positive. So that's going to be above here. Okay, that is a continuous section on my graph. It's this full section here, so it's a continuous portion on my graph. It's between those 2 x values, so it's after that 0.4, but up as far as that 3.7. So if I was saying it in words, would say that. So between 0.4 and 3.7, and then to say that mathematically, we can always look back at the domain in the question to remind ourselves how we laid out. 0.4 less than x less than 3.7. For where it's negative then is going to be the opposite to that. So it's when x is less than 0.4 but greater than 3.7. So the reverse of what we just had. So there is quite a huge amount there. There is a lot. Don't let yourself be thrown off by the descriptions that I've provided here. What they're supposed to do is that if you were unsure of a certain type, that you would have somewhere to go back to and to refer to. But the key thing for all of these questions is to identify whether you know or have been given X or Y, and therefore whether you're looking for X or Y. And that's going to be the really important thing for you moving through all of these questions.